Algebra 2, target 25. I can sketch the graphs of simple exponential and logarithmic functions. The focus today is on natural base exponential functions. That's f of x equals a times e to the rx. And logarithmic functions. F of x equals log base b of x divided by a. If we take a look at y equals ae to the rx, we're going to look at the parent function. That the parent function is y equals e to the x. You'll notice the shape, pretty much the exact same thing. The exact same thing as what we had yesterday. A few things to point out. Your y-intercept, that's the same. Whether r is negative or positive. The next point you'll notice is 2.718. If you remember, that's what e is. So you're going to be doing the same thing. You're going to be multiplying as you go right, dividing as you go left. Here, e to the negative 1 is our exponent. Multiply by that as we go right, divide as we go left. You notice that negative 1 divided by negative e, gets you at e. So basically, if our base is e in the exponent problem, it's the same thing with the difference that now our base is e to the r. So that's what we're going to be multiplying by as we go left and right. E to the r instead of just the e. Everything else stays the same. Now logs. How do you graph a log? Well, if you remember, a log and an exponent, those are inverses. Right? Exponents and logs are inverses. So because they're opposites, we can just reflect them over the line y equals x. Here's the line y equals x. That's where x and y switch, which is how you find an inverse. You switch x and y. So the point 0, 1, this point here is 0, 1. When you switch them, it becomes the point 1, 0. So this point reflects down to here. And all these points here will reflect down to here, and these points, you'll switch them and they'll reflect down to there. So the log, basically the same idea, except we're reflected over y equals x. Everything that's done in x is now done in y. Our asymptote right there, instead of being horizontal, now becomes vertical. Right? And if we have a value of b that's negative, it's the same thing. Instead of exponential decay, we're going to have a log that reflects down like that. Right? So some key differences for logs. Asymptotes are vertical instead of horizontal, and the x and y coordinates are flipped. That's by the definition of inverse. So instead of starting at a and then or 0 in the starting point, you're going to start at a and then 0. And then to go up and down on the y's, you'll multiply by the base of your log to go up, and you'll divide by the base of your log to go down. So let's hit up a few examples. Graph the function y equals 3 times e to the 0.25x. So first off, let's identify our starting point. It's always important to know where do we start our graphs at. Our a value here is 3. This is our starting point. That's your initial value. So on the a-axis, or on the y-axis, we'll plot 3. Now what is our b value? Our b value is 3 to the 0.25. That might be a good number to approximate out. Hold on a second. E to the 0.25. E to the 0.25, not 3 to the 0.25. So let's approximate that out. E to the 0.25 is 1.28. So our growth factor is 1.28. So at x equals 1, we're going to take 3 times 1.28. That'll be our next point. I'm just going to do answer times 3. 3.85 is at x equals 1. That puts us right about there. And to go backwards, at x equals -1, we're going to take 3 and divide by 1.28. So we'll take 3 and divide by 1.28. I'm going to use the exact value of e to the 0.25. And we go backwards to 2.34. Right? So you can kind of see this one is not as steep as other ones, but you can kind of see the growth here and the asymptote as we come back that way. Okay? So there, that's the only difference. You just got a different base when it's e. So let's graph this one. Y equals log base 3 of x. Keep in mind, our a is going to be located underneath the x. There's nothing underneath the x, so that means a is equal to 1. B equals 3. This time, instead of going left and right, we're going to look at what's happening up and down. Right? So our x-intercept is our a value. A equals 1. So as we go up the graph, we're going to multiply by our growth rate. 1 times 3, the next point will be 3. So we go up 1, the next point should be 3. If we go down, it's going to be the reverse of that. We're going to divide by the growth rate. Divide by 3. It'll be 1/3. And then we'll still make the same shape as the exponential. It's just going to be turned. We're going to have ourselves a vertical asymptote at x equals 0. And looking at the next problem, same thing. Need to figure out what our a and our b is. There's nothing underneath x, so that means a equals 1. B in this case is 1/2. So we're going to start at 1. And then as we move up, we're going to multiply by our growth rate. 1 times 1/2 is 1/2. And as we go down, we're going to divide. 1 divided by 1/2. That's the same as multiplying by the reciprocal. It's 2. And so you see we're going to have the same basic shape, just going the other way, because our growth rate, or our log rate, is a fraction, less than 1. And we're still going to have ourselves a vertical asymptote at x equals 0. So a summary. Steps for graphing y equals log base b of x over a. First off, identify a and b. Most of the time, and all the time we've done it, but most of the time your a is going to be equal to 1. Step 2, identify asymptote. Normally it will be the y-axis. The equation for the y-axis is x equals 0. We're going to plot the points starting with our x-intercept, and we're going to multiply to find one value higher and divide to find one value lower. Then we're going to draw a curve starting along the asymptote and then out through the 3 plotted points.